Welcome to Knowledge Exchange, where I talk about technology and I talk about human psychology. Today, I want to talk about time complexity, space complexity, and big O notation. As it is known, time complexity and space complexity are the critical components to determine the quality of algorithms. So it's very important to understand these terms. Let's understand this with a very basic function. I have a function count which gives you the count of numbers whether it is even or odd from the input collection. And to do so, the step 1 is to set counter to 0. Step 2 is to iterate through the numbers collection, and for each number in step 3, check if number is of particular type. Step 4 is increment the counter by 1 if there is a match, and step 5 is to return the counter. Now, to understand the time complexity, if we look at step 1, step 3, step 4, step 5, as an individual or standalone lines, they are going to take constant time depending on the infrastructure they are running on. So we can say that step 1 is going to take C1 constant time, step 3 is going to take C3, step 4 is going to take C4, step 5 is going to take C5 constant time. Whereas when it comes to step 2 is iterative in nature, so it's going to take n into C2 constant time. And when you combine this together, you get the equation something like this: C1 plus n into C2, and then in the parenthesis you have C3 plus C4 and then plus C5. So this is the time complexity expression of this particular function. Now, to drive the big O notation, there are two rules which has to be applied on this equation. First, consider the dominant factor and take away the remaining ones. So in this, if you look at this expression, there are three components: C1, C5 and this particular equation. So this becomes a dominating factor as compared to C1 and C5. And similarly, if we have n into constant and we have n into constant, in that case n into constant becomes a dominating expression. So we take out everything else and then we are left with the dominant one. Once we have the dominant one, we apply the second rule, which says that drop all the constants. So we drop C2, C3, C4 and we get big O notation, which is O of n. So this indicates that how the time complexity of this particular function will grow as the size of n grows. Now let's talk about the space complexity. In this particular function, we are basically initializing only one variable, which is counter. And in step 4, we are incrementing the same variable value by 1. So ideally speaking, for step 1, we are taking a constant space. So the time complexity is C1, let's say in a space term. And when we convert this into big O notation using the dominant rule and the constant rule, we get O1. So for this function, time complexity is On, whereas the space complexity is O1. Thank you so much for watching. Have a good day.